I'm Anil Kumar, and here is a test question for you. Let us say we have a composite function f of g of x. That means f is composed with g to provide you with a composite function. And for simplicity, what I do here is that I say first the inputs will be processed by the function g, right? So what we say that these are the inputs for us, which in this case is f, and on which this operation is performed, and the output which you get from here is g of x, right? And now on these outputs will perform the operation f, right? The second function's operation, outer function, and the output which we get will be f of g, right? That is what we are saying. Now in this input output machine type of a correlation, what do you think is incorrect? So these are the inputs which are going to the function, inside function, and then of course you get an output, and these outputs will get into f, and the output of that will be f of g, right? Now that is a simpler way of explaining composite function, but here what do you think is the drawback? Now this is not exactly right. The mistake here is, so we have to find what is the mistake in this particular explanation. Mistake here is that the outputs of g of x, some of them could be, the outputs of g, which is g of x, could be such that they cannot be processed by f. So not all will get into this function. Do you agree, right? So we have a restriction here. So restriction here is that only those outputs, so we have a kind of filter here. So from here, only those g of x which can be processed by f, that means only g of x which is in the domain of f of x will be processed. Do you understand? Not all. So there is a kind of filter. So there could be some outputs which cannot be processed. Let me take an example to explain the situation. For example, if I have function g of x as 2x minus 1, a straight line. Now in this case, there is no restriction in domain and range, correct? On the other hand, if I have the function f of x as, let us say, square root of x. Now what happens? So what happens really is that at this stage, what we get is kind of a straight line, right? The output for all the real inputs, so x belongs to real numbers, is your input. And what we get here is kind of an output like this. Now the whole output cannot be fed into the second operation of square root of x, since it has a restriction. Do you agree with me? So the only outputs which are positive, those outputs can be fed, because these are not in the domain of f of x. You get the idea, right? And therefore we have to incorporate this particular definition and understanding in our input-output diagram, right? So all the valid inputs of g of x will form the domain of f of g of x. And out of that domain, we have to exclude those which will result into, in this particular case, negative values. Do you get the point? So as you can see here, for g of x equals to 0, we have 2x minus 1, so x is equals to half, right? So this is x equals to half. And therefore, if I'm considering the domain of this particular function, then what should it be? Domain of f of g, right? What should it be? That is the question. I hope you have the answer now. The answer is x belongs to real numbers, where x should be greater than half or equal to half. Is it okay? Since only if we have a value of x which is greater than or equal to half will give us g of x, which can be processed further by our second function, the outer function. You get the idea. So that is how our input-output operation is slightly different from the composite function's input-output, right? So therefore, in this particular case, we say that the domain of f of g is set of all numbers x in the domain of g such that g of x is in the domain of f of x. So remember, g of x should be in the domain of f of x. Do you understand this? So that is the concept which you need to understand, and based on this concept, we have one example here. We'll have a few more, so that this point is well taken care of. I hope you appreciate it. I'm Anil Kumar. You can subscribe to my videos and understand a lot. Thank you and all the best.